Okay, like I said, I'll work whatever ones of these you want to work, and we can work these until we run out of time. But it's totally up to you. So, if you have a question over something on that worksheet, you can bet you're going to see it on a quiz tomorrow. So, anybody got anything for me? Something you want to see worked out of these 18? Speak now. All right. Caitlin? Number 11. She would like to double check. So let's get up to number 11. It doesn't matter what order we go into. Number 11 tells me aluminum and water. Okay? Aluminum and water. First thing I have to do is I have to identify what type of a reaction this is. What do you think about aluminum and water?
I thought that it was number 2 because that's the only one that has water with it. But the problem is aluminum isn't an active metal. Because you said
Okay, well, let's look. Okay? Let's look at some of these first of all. All right? Now, people, I'm not going to have other people talking while we're talking. If you want to work on your WebAssign, work on it. But don't be talking while other people are trying to get this. Let's look at the combinations. Okay? The combinations. It's not a nonmetal oxide. Could it be an active metal oxide? Well, we said on the active metal oxides it had to be what? A group 1 or 2, right? Okay? So, let's look down at the single replacements. Could it be an active metal and water? Let's look, okay? Because that is one that we have on our activity series. And I'm going to pull up my activity series here real quick so we're all on the same page of what I'm looking at. So here is my activity series. I think I already had it up. But you're going to see that I have 2 lines right here. The one down at the bottom right here is telling me reacts with steam liberating hydrogen gas. That is single replacement number 2. But it has to be steam. Here is reacts with water liberating hydrogen gas. So, what do I have? Well, I have aluminum, don't I? So in order for aluminum to react with water to liberate hydrogen gas, the water has to be steam. Does it say steam here? No, it just says water. So when I go back to number 13 here, I would say aluminum plus water will not react.
right, but aluminum's not an active metal, so how come we can even do number 2A? You know what I mean?
Because my activity series. I didn't say a group 1 or group 2. Okay? If you look in the combinations, it says right there, it needs to be a group 1 or a group 2. Okay? It doesn't say that for this one. For single replacement number 2, it doesn't say that. We have to look at our activity series. That tells you whether it's active enough. Okay?
I was thinking of that
Group 1 or Group 2? Okay. No, not in this case. We check the activity series. All right, good question. All right, give me another one. Number 14. Okay, number 14 looks to me like I have an aqueous salt and an aqueous salt. So this is going to be a double replacement number 1. Now, on a double replacement number 1, I need to swap my cations. So, first of all, I'm going to name them. I have calcium acetate, and I have iron 2 nitrate, now, what is that going to flop to give me? Well, it's going to give me iron 2 acetate, and calcium nitrate. Now I need to look, okay, at my my solubility chart, because I need to have one aqueous and one insoluble. So I look up iron 2 acetate. Iron 2 acetate is soluble. Calcium nitrate. Calcium nitrate is soluble. What happens if both of these are soluble? Does not occur. It is no reaction. So I did all that. I'm going to erase it. I'm going to clean it up. And I'm going to say that those two will not react. That is an NR for number 14. Okay. What else? Anyone else have any that they would like to see?
Can you tell me what the symbol is for ammonium?
Ammonium? It's on your PAL. Okay, it's the very top one to the left, NH4 plus 1.
That's what I was thinking about. I didn't see it on there, so I was trying to look for it. That's why I didn't do that one.
Okay. Any others?
I don't know.
18. All right, let's go 18. Okay. All right. Copper 2 chloride. Okay, first of all, when I'm looking at this, this is also a double replacement number 1, because I have 2 salts there. So I have copper 2 chloride, and I have ammonium hydroxide, NH4OH. What I'm going to do is I am going to flop. So I have copper 2 hydroxide. Make sure you don't switch the coppers. And I'm going to have ammonium chloride. Now, I know, ladies and gents, I know right now that this is not balanced, but I'm not going to worry about balancing it yet until I know it happens. So, I flopped them. I'm going to look at copper 2 hydroxide. Copper 2 hydroxide is an I, right? So I put that it makes a solid. Ammonium chloride is an S. So it is AQ. Do I need to put that S and that AQ on there? Do I need to put that S and AQ on there? Absolutely. Or you're missing points. Now, will this reaction occur? Will this reaction occur if one is soluble and one is insoluble? Yep. So what do I need to do now? I've got to go back through and balance it. And I'm going to have to put a 2 here. And I believe a 2 here balances it up. Yep, 2 and 2 right there. Balances it up. Okay? Any other ones? Any other problems? Go ahead. Oh yeah, you'll see them. Just because we didn't do one on this reaction prediction, there might be 3 of them. Can we do a different double replacement? One that is not 2 aqueous salts? Okay? So let's say I'm going to pick out with what? Okay? I'm going to do a new one. Okay, so let me call up a new page here. Okay? And we said hydrochloric acid. Okay? Which one you want me to do? Alicia? Number 5. Okay? An acid and a sulfide salt. Okay? So let's just put a sulfide, IDE, so that's sodium sulfide right here, will yield a salt and hydrogen sulfide gas. So I am going to get a salt. Well, what is my salt here? NaCl. Okay, because what I'm basically doing again is I'm flopping the cations. So I put the Na with the Cl, and I'm also going to get hydrogen sulfide gas. Now, I could put an up arrow here. Okay, I could put a G here. I could do either or, because I know that it is a gas that is being formed. Now, do I have a balanced chemical equation? Not yet. Okay, I need to put a 2 here. I need to put a 2 here. Okay, 2 sodium, 2 sodium, 2 chlorine, 2 chlorine, 2 hydrogen, 2 hydrogen, 1 sulfur, 1 sulfur. Okay? Now, did I need to check my solubility chart? No, because that's only when I'm dealing with aqueous salts, 2 of them. Okay? Anything else, folks? Now's your time. Now's your time to speak if you want to see something. We good? First row good?
I have 16 and 17 circled, but I'm not sure why.
16 and 17. Well, let's go back. Let's go back and look at 16 and 17. We can do that. 16 is calcium plus aluminum chloride. So, I identify it first, and I'm going to say, okay, this is a single replacement. Now let me go through my single replacements. Is it a metal and an aqueous salt? Well, yeah, it is. Is it an active metal and water? No. Is it a metal and an acid? No. I don't have a halogen to start with. Is it a metal oxide and hydrogen? No. So this is a single replacement, number 1. Now, what's going to happen is I have calcium, and calcium is going to try to replace aluminum in aluminum chloride. So I look at my activity series. Is calcium active enough to replace aluminum? Is calcium higher than aluminum? Yes. So calcium will replace aluminum. So this gives me calcium chloride, and I have aluminum being given off. Now, do I have a balanced equation? I do not. What do you think my biggest problem is going to be? The negative and positive? The odd and even of chloride, right? So I've got to make that odd even. Okay? And I got to make this even more even. So now I have 6 chlorines. That threw off my calcium. Now I'm good. Threw off my aluminum. Now I'm good. Okay, well, you did it right. Now, you wanted to see the last one too, right? Or 17. 17 is silver plus mercury 1 nitrate. Now, mercury 1 nitrate is a funny one. Silver is Ag. Now, mercury 1 is Hg2 2 plus. Okay? You just got to memorize that. If you don't believe me, look at your ion sheet. So, I have, let me switch to my other page. Here is mercury 1 nitrate. I believe that's what I was dealing with, right? Okay. Mercury 1 is that right there. Hg2 2 plus. Okay. I told you, it's an exception. You have to memorize it. Okay. So, in order to have these, all right, in order to have this charge equal a net charge of 0, I need 2 nitrates, correct? So, what I'm actually going to see is it's going to be Hg2 parentheses NO3 2. Now, can I have that? Because it looks like you can reduce them. Yeah, I can have that. Okay? Yeah, I can have that. So let me go back. As I come back here, come all the way back down. So Hg2 NO3 2. Now, this is going to be just like the one I previously did. This is a single replacement number 1. So, will silver replace mercury? Well, there's not a whole lot that silver will replace. But guess what? Mercury is one of them. So, I'm going to get silver nitrate and mercury is going to be released. Now, am I balanced? Am I balanced? No. Okay? I need to have 2 nitrates. I need to have 2 mercuries. When I've done that, that tells me then that I need to have 2 silver. So now I have those guys balanced up. Okay? Any others? Good? All right.